Hello class, welcome back. Hopefully that your family's healthy and you're taking care of yourself. Today what I would like to do is kind of go over the solutions to the Google form that I submitted on Sunday night or Monday morning for you. I'm going to try to keep up this format where I try to do a video kind of every other day or submit an activity for you every other day. So Monday, or I guess Sunday night, but Monday morning, for you I submitted out a Google form via your Google Classroom for you to try out some factoring problems for polynomials. I think Tuesday I submitted another activity where you could check out another website and, practice more factoring. Well, today I want to go through those answers on that Google form. So if you haven't had a chance, you can hit pause, go back and try out that video, or try out that activity and see how well you did. But I want to give you the answers because I think that's important. So if you go open up that Google form now, you can kind of go check out some of the problems we did. I'm going to go in the order that I submitted them. I know they might have been randomized to you, but I thought it was kind of important that we go through those and so you know what the final solutions are. So without further ado, let's jump right in. I believe there was like 14 or 15 questions, so let's get going. The first one that I had on that form, if I kind of go through this here, it was 16x minus 24. The first three problems I had on there were on common factors. So on this particular problem, if I kind of look at both these problems, it looks like they both have an 8 in common. I'm going to pull an 8 out of that. So when I divide it both by 8, I get a 2x and a 3, and that should be the final factoring of that problem. Again, it's just common factors. I noticed they both had 8s in common. You could pull out different numbers, but you try to go for the biggest number. That's the best way to do it. But again, let's jump right into the next one. So the next problem that we had on that Google form was 4x squared minus 8x. So again, it was a common factor problem. On this problem, both terms have an x, and they both had a 4 in common. So I'm going to pull that out. When I divide a 4x out, I was left with 1x in the front. You don't need to have the 1 there. I'm just putting it there so you know it. And then for the 8, if I divide a 4x out, I was left with a 2 there. And again, the item inside the parentheses should be the same size as the item that you started with, so it should be a binomial still. So it was x minus 2 if you want to write it like that. All right, that was the second one out of the common factors. And the third one out of the common factors was 6x to the fourth minus 18x to the third plus 12x squared. So on this problem, it was a trinomial, but they all had something in common. They had a 6 in common and an x squared in common. So when I pull that out, it'll be an x squared left over, 1x squared if you want to write that. Then it'll be a 3x, because I took out 2 of them. And then in the back, it was just a 2, because I took out a 6 and an x squared. So now I know this part can go further. I didn't require that. You could recognize this parenthesis was a trinomial, but the common factor was the 6x squared. Now, if you want to go further, this would have been a trinomial rule. You just leave the 6x squared on the outside. It'd have been a minus sign, break up the x squared to be x and x, and break up the 2 to be 2 and a 1, and it would have made the 3 in the middle. You didn't have to get to this part. It was just something that maybe you noticed it. You didn't have to submit that. All right. Going to the next ones. Now, these next 3 that I had were on grouping. Now, they could have been later in the list for you because I know it was kind of randomized. But I'm going to go through these. These are the next that I had submitted on the form itself. Grouping is by far the hardest kind of method of factoring. I'm going to switch up the color here. So the first one we had was x cubed minus 3x squared plus 4x minus 12. And what gives it away that this should be grouping that there's 4 terms and you can't add or subtract any of them. So I'm going to group the first 2, pull out an x squared here, so that's x minus 3. In the back, I'm going to pull out a 4 here, so pull out a 4, that's x minus 3. And so I noticed that they both had an x minus 3 in common, so I pull that out back, just one of them. And what's left in front of that, if I can write my parenthesis down, there we go, is an x squared plus 4. And that can't go any further. It's a sum, it's not a difference, so it wouldn't go any further. But that's your final factoring. So that was the first grouping one. Again, grouping, this is the hardest part, is just recognizing that you have to pull the x minus 3 from both. And it's just one of them. You're not pulling 2. It's just one item from each. So, all right, let's go to the next problem here. This should be x cubed minus x squared minus 5x plus 5. So in the front, I'm going to group these two. I have an x squared, so that's x minus 1. In the back, I'm going to pull out a negative 5 here, so that's x minus 1. So because I divided a negative 5 out, so that's why the back one turned out to be a negative 1. And so I notice they both have negative x minus 1s in them. Sorry, not negatives, but x minus 1s are in both parentheses. And I'm left with this. That's left. Now, this is not a difference of squares. You could attempt to do it that way, but you don't have to, because 5 is not a perfect square. But that'd be the final factoring that I would accept. All right, let's go to the last grouping problem here. Last grouping one was x cubed plus 6x squared minus 2x minus 12. Grouping these two, I have an x squared, so that's x plus 6. In the back, I'm going to pull out a negative 2, so it's x plus 6 again, pulling out a negative 2. And then I notice I have the x plus 6 in common, so that was an x squared minus 2. And you can't go any further. This is not a difference of squares. I know there's a way to go further with that, but that's not something that I would expect you to know how to do. So there you go. That's the factoring for all the grouping problems. There's 3 of those. All right, let's switch up the color. Let's go through the next ones here. So the next one should be trinomial rules now. These are by far, I think, not the hardest, just the ones that take the most time, because there's so many weird rules you have to do here. So, all right, this is the first trinomial that we had to do. Again, trinomial is 2 parentheses. Break up the front, so the x and x. Break up the 15 in the back. I'm going to go 5 and 3, and it's a plus sign and a plus sign. Now, how I know that? They're the same. They're both plus signs. So that's how it works. So that's the factoring of that. The next problem. It was 3x squared minus 2x minus 5. Now this one's hard because it has a 3 out front. That makes it more challenging. This might take a couple of trial and errors. It's going to be a plus minus in these because the minus sign in the back automatically makes it plus minus. Breaking up the 5 and the 3 to make the 2. I'm going to go with like a 1x and a 3x for the 3x squared, breaking that up kind of evenly. I can't go decimals on that. And then I'm going to go the 1 and 5 route because I think that'll make a negative 2. So this should be the factoring of it. So if I FOIL, that's 3x squared. That is a negative 5x. That is a positive 3x. And then a negative 5. And that does make a negative 2 in the middle, so that is the correct factoring of it. Again, how I knew how to do that, it's seriously just trial and error. It's just breaking up the numbers, the 3 into 2 numbers, and then the 5 in the back, and then 2 numbers, and it's just putting them in the right spot so I get the negative 2. Luckily, these numbers, like the 5 and 3, were like prime numbers, so there wasn't like a ton of combinations I could have done. But it was factorable. All right, let's jump to the last trinomial rule here. I tried to do 3 of each. The last one here was x squared minus 14x plus 45. So 2 parentheses. They're the same operations in both. It's going to be a negative negative. They're the same. That's what this plus sign here tells me, but they're both minus signs. That's an x and x. And then I have to break up the 45 to 2 numbers that multiply to give me 45, but will add to give me 14. I'm going to go 9 and 5. Those multiply to give me 45, and they add to give me 14 in the middle. Or technically subtract, I guess. 2 negative signs. But there you go. All right, so those are all the trinomials. I had 3 of those. The next ones, I believe, were difference of squares. So let's switch up the color here. Let's go the difference of squares route. All right, so let's factor these up. The next one was x squared minus 144. So it's difference of squares is 2 parentheses. It's plus minus x and x, and then I break up the 144 to go 12 and 12. It's the easiest because these are like perfect squares, so it's just there's only one way to do it, so it cancels out the middle term. So that was the first one. The second one, I believe, had 2 numbers now, not just 1. So I had 64x squared minus 81. So 2 parentheses again, plus minus. That's how it always works. 64 is 8x and 8x, and then the 81 is 9 and 9. That will give me the 81. And if you FOIL first and the last, the middle term will drop out again. All right, and the last perfect square. The last perfect square should have been 36x squared minus 49y squared. So again, 2 numbers again, plus minus. So 36x squared is 6x and 6x. And then the 49 is 7y and 7y. And that should FOIL out first, outer, and last and give you the 36x squared minus 49y squared. All right, the last three problems should have been cube rule. Cube rule is where it's perfect cube numbers. It doesn't matter if it's add or subtract. These will factor up no matter what. The first one is x cubed plus 27. So it's a small parenthesis, large parenthesis. You take the cube root of these, so it's x, plus sign, and the cube root of 27 is 3. And these items help me figure out the back. It's going to be the opposite sign and always positive in the back. X squared, because it's the first item squared. The middle is the two items multiplied together, and then the back is the back item squared. Which, if you don't want to write 3 squared, you can write 9. It's fine. There you go. There's the factoring of it. That's done. This can't go any further. I know it looks like a trinomial, but it's prime. It won't be able to be factored. That's the way that this thing works out. If you FOIL it out, it does give you the x cubed plus 27 back. So if you can always check by multiplying it back together. All right, second to last problem here. 8x cubed minus 1. 2 parentheses, one big, one small. The cube root of 8x cubed is 2x, and then the cube root of 1 is 1, and the minus sign is in the middle. It's going to be the opposite symbol, and then always positive in the back. The front item, so 2x squared, that's 4x squared. The two items multiply together, 1 and 2x multiply together is 2x. And the back item is the 1 squared, which is 1. And again, you ignore the negative signs and whatnot because we've already done all the signs. So there you go. If you FOIL it out, first, outer, and last, it does actually work out to be 8x cubed minus 1. And the absolute last cube problem that we have, I believe it has two numbers in it. 64x cubed plus 27. So it's small parenthesis, large. This should be, the cube root of 64 is 4, and then x, and then the plus sign, and then the cube root of 27 is 3. And those two numbers help me figure out the back. So it's going to be an opposite sign, then always positive in the back. 4x squared is 16x squared. The middle term is the 3 and the 4x multiplied together, which is 12x. And then the back item is the 3 squared, which is 9. And again, you shouldn't be able to factor this thing apart. It should not make the 12 no matter how you do it. But there you go. That should be all the problems from the Google form. That was all 15 of them, I believe. On Sunday night or Monday morning, I'll submit out another form. I think this time we're going to go through radicals. So I think we're going to go through square roots and whatnot. Simplifying radicals. See if you know the rules. But I'll try to do the same format every other day. I'll submit out an activity or a video, and I'll try to always give you the answers by the end of the week for it. Hopefully you're doing well. Hopefully you're healthy. If not, please take care of yourself. And I'll hopefully see you later. Okay, bye.